Sure. Okay. Can you connect all 9 dots with only 4 straight line segments without losing contact with your paper? It is possible. Okay, I'll show you how to do it. We're going to take one line, draw it up. Then I'm going to go down through these 2. Then I'm going to go left through these 3 and back up through this 4. It is possible. Yes. No, I want to get started. I haven't got any time, so maybe tomorrow. Show me tomorrow. Did it work? Really quick. Really quick. Come on up. Come on up. Come on up. Get a pen. Let's see. Let's see if it works. Do on the dots. Do on the dots. No, can't pick up your pencil. Nope, wrong. You can't pick up your pen. So it has to be continuous. Drawing the X's will not work. Sorry. It does say, but it's okay. Okay, here we go. Here we go. Now, today's lesson will be the following. Okay, solving variable equations. It's also called literal equations. So copy that down. Copy. Get it. Okay, that's the title of it. Now, today's lesson is very straightforward. Because we are able to solve our multi-step problems, okay, the only difference now is we're going to be able to do that with just letters. And so that's going to be kind of what we need to get at. We're going to do about 8 examples. After we're done with that, I'm going to give you guys your homework, and you guys will be good to go. Okay, good to go. So check that. Is Angela here today? Let's see her. Nope. Okay, so this is solving variable equations or literal equations. Okay, this is the next part I want you guys to write down before we jump into it. The process of solving formulas for a given variable is called solving variable equations or literal equations. Okay, so solving for variable equations may just be another way of saying take the equation with lots of variables and solve for one variable in particular. We're going to look at an example that has the same kind of letters, but it will kind of move towards the independent stuff as we go along. So we're going to start with 1 variable, then 2, then 3, then all of them will be variables. We'll look at several examples, and then we're done. So copy. After this, we only have one slide. I'm just telling you the rules of how to really solve them out. It's nothing too tricky, but I want to just give you guys just an outline. You guys have solved these before. We're going to kind of come back and look at them. This week we were doing literal equations and inequalities, solving inequalities. So it's going to lead us into slope, point slope, slope intercept, standard form. Yes, but I don't know yet. I'll show you an easy way of doing it. Hopefully. Can I move on? Good. Okay, moving on. These are the rules to help you solve them. Okay, this is the last one before we start doing problems. Okay, so the rules to solve literal equations. Identify the variable that needs to be solved for. So we're going to highlight that in this case. You guys can circle it if you guys do not have a different color pencil. Okay. Use the undoing operations to solve. Okay. What do you think DCMXAM stands for? Don't call Mexico after midnight. That still holds. Okay. The only difference is distributive property we'll need sometimes, not always. Okay. The undoing operations of combined like terms won't really happen because they're all different variables. And the move small value of x won't need to be happening because you're only solving for one of them. So what you're really looking at is the last two parts, which is the DAM, the DAM. Okay, distribute, add or subtract, multiply or divide. Those become the two key ones. I believe it is a lot easier to do these ones because you're not multiplying, you're not really subtracting out like terms. Okay? The like terms are only one variable and they're all different. So you can't really add or subtract them because they're not the same. And that's going to become key when we're doing this. Okay? If terms cannot be grouped together, okay, we're going to put parentheses around them to group them up just so we know what we're doing. So we're not messing up at all. Okay? And that's the only real difference is if we can't subtract them, we're just going to put parentheses around them or brackets or whatever have you. Okay, it's just going to help us delineate between the different groups. DCMXAM. Distribute, combine like terms, move small value of x, add, subtract, and multiply, divide. Can I move on? Okay, am I getting a no? Okay. So copy those 4 types of problems over. We're going to be looking at solving them. Okay, again, one is one example. They're very the same. They're all very same. Okay, the only difference is we add a different variable every time we do it. Okay, so we're going to look at those and solve those out. If you want to make a column or something like that or just put them near each other, you guys can do that. Okay, let's start on one of these. I'll let you guys finish those up as we do them. Okay. Solving for the one variable where we want to solve for m. So I'm going to go ahead and highlight m. If you want to circle it, you could circle m. We've done plenty of these. What's my first step? So it's add or subtract out whatever term's next to it. So we're going to subtract out 4 to both sides. And then do what? Simplify. So 2 minus 4 is what? Negative 2 is equal to 3m. And then we want to multiply or divide out by the one next to the variable. So we want to do what? Divide out by negative 2. We're trying to isolate a variable by 3. So this is going to give me m is equal to negative 2/3. How many people got me from there? I got it. It's pretty straightforward. You got it. Okay. Now let's look at this next one. Okay. We now have 2 variables. We have an s and an m. Okay. We're going to go and highlight a variable again. And let's follow that same kind of practice. Okay. Distribute, don't need to do that. Combine like terms, don't need to do that. Move small value of x, don't need to do that. Add or subtract one of our terms. So what should I do? Subtract 4. So just as we did. Subtract 4 from both sides. Now the question is, can I subtract s and 4? Can I? No, they're not like terms. So if they're not like terms, we just rewrite it. We're going to write it as parentheses s minus 4. Those are not like terms, so we can just write them like that. We're going to subtract 4 from s. Whatever s has to be, we can't do that. Is equal to 3m. Okay, and we're still going to finish it off. We got to get m by itself, so divide both sides by 3. We're going to go ahead and rewrite it. S minus 4 over 3. My 3 and 3, oh, that's a bad place to put it. I'll write it lower. S minus 4 over 3 is equal to m. Again, we're solving for a particular variable. That's how we have to do it. You see what we're getting at this? Okay, I'm hoping you guys are. Okay, looking at the next one, we have S, M, and R. So this time we have 3 variables with 1 coefficient. So doing the same process, we have to add or subtract out. Subtract out what? R. R is right next to it. It's a whole term, whatever R has to be. Can you subtract R from S? Nope. So we're going to leave it as S minus R is equal to 3m. Okay, still following our steps, still trying to get m by itself. What should I do? Divide both sides by 3. Our 3's are going to cancel, leaving me S minus R over 3 is equal to m. This is kind of making sense? Something different. Okay, last one, given all variables, solve out for m. We could still do that. It's almost following the same process, right? So what's my first step? Subtract r, subtract r. We know we can't reduce s and r together. We can group them. True. Okay. This time a is being multiplied by m, so how do I get rid of it? Divide by s minus r over A is equal to Are we good? What do you guys think about this stuff? Easy? Hard? CSU? Okay. Okay. Let's look at another set of type of problems. And I'm going to kind of jump to, copy down that one. Okay. This is another way of solving it if you choose to do it that way. Copy that down. You want to make another chart. So make this chart. We're going to do one problem, then we're going to do one right next to it. So if you want to make another part of that, go for it. You only need to write it once. This is another way of solving it. Okay. Solving literal equations is very helpful when looking at various types of actual formulas. Okay, formulas are literal equations because they have multiple variables in it. Now looking at this formula, can someone tell me what it's from? P is equal to 2W plus 2L? Of what? It's a perimeter of what? Rectangles. The perimeter is equal to twice the width plus twice the length. Awesome. Good job. Good job. Good stuff. Okay. Given different parts of the rectangle, you can actually find out what different inputs you need. In this case, width, length, or perimeter. Okay. It is a literal equation because we have perimeter P with W, length L. Okay. And this works out the same way every single time, 100% of the time. Okay. If you follow these steps going down, it does the same thing. Okay. This is the same thing as you do not call Mexico after midnight thing. Okay. So, solve for L. Solving literal equations. Okay. About 15 more seconds before I begin. Now what I want to do with this first one is I'm going to go ahead and highlight my variable. In this case, you guys can circle it, but I'm solving for L, so I'm going to highlight L. I'm going to go ahead and write it down below. P is equal to 2W plus 2L. Okay. It said add or subtract out the term that is not circled. In this case, add or subtract out the term that is not highlighted. What term is not highlighted? 2W. So we're going to subtract that out to both sides. Can I subtract 2W from P? No. This is going to go away. And I'm going to be left P minus 2W is equal to 2L. Multiply any number in the denominator. So this is the denominator talking about fractions. Do I have a fraction? Anything with 2L? No, so we're going to take it and just rewrite it. All right, P minus 2W is equal to 2L. Divide anything that is next to the circled variable. In this case, the highlighted variable. So what should I divide out? 2. For both sides. When we simplify it out, we can't reduce that side down because they are not like terms. So we're going to get P minus 2W over 2. But on the right side, we can reduce that down. 2 over 2 becomes 1. And we're just left with L. Easy or hard? Solving for literal equations. That's what we're looking at. Literal equations. Okay. Let's look at another type. Copy that one to the chart right next to it, or problem right next to it. C is equal to 2 pi r. What is this one from? What formula? Circumference. Circumference of a circle is equal to 2 pi r. Area is pi r squared. The symbol? Pi? 2 pi r? Circumference? If you haven't done it, don't worry about it. You'll learn it. Just copy that down. Just copy that down. Now, you guys should already have this written down. Didn't take me that long to write it down. Okay, I'm going to go and highlight my variable, in this case r. Do I need to subtract out any terms? No. What about multiply by the denominator? So we're going to skip 2 of them. I'm going to rewrite it. C is equal to 2 pi r. Divide anything that's next to the variable. So what is being multiplied? 2 pi r, in this case 2 pi, so I need to divide out by 2 pi to both sides. When we simplify out, we're going to get C over 2 pi is equal to r, the radius. Easy or hard? Hard? A little bit? Just a little bit? We're just solving for a variable. In this case, it's asking us to solve for the variable r. So we're trying to get r by itself. That's all we're doing. That's all we're doing. Okay, we have 2 more examples and I can let you guys be free. Wild and free. There you go. Okay, copy down the following. Looking at this equation. Okay, and this time our formula is in standard form. This is called the standard form of a line. We're going to look at this a lot more coming in the future, looking at slope-intercept, point slope, standard form, slope of a line. Okay, y equals mx plus b. Okay. We want to be able to solve for these little formulas. In this case, it is a little formula because it has more than one variable, that being x and y. So we're going to look at these. If you follow this kind of pattern as well, this works the same way. Circle the y term, add or subtract out the x term, divide by the y coefficient, and then that's your answer. Okay. Looking at our equation, circle our y term, so I'm going to rewrite it. 10x minus 5y. We're solving for y, so that's going to be my highlighted value. Is equal to 15. And go ahead and drop it down. 10x minus 5y. Now, what is my x term? 10x, right? So we want to add or subtract it. Subtract it. Positive 10, so I want to subtract out 10x. I want to be able to subtract. Okay. Our 10x from our left-hand side will be reduced. I'm going to be left with negative 5y is equal to, and I'm going to kind of flip this around. Okay, it's going to be negative 10x plus 15. Putting the variable first, the variable term first, coefficient last. Okay, this hopefully is going to look like y is equal to mx plus b. Remember that? Yeah. We're going to kind of get to that. So we're going to build up our way onto that. Okay, the last thing is divide by the y coefficient, which is negative 5. So we're going to divide negative 5 into both sides. Our negative 5s are going to cancel, leaving me y is equal to negative 10x plus 15 over negative 5. It's still right, but I want you to start getting used to writing it the other way, because it'll become more important when we start getting to slope-intercept. Yes, you can, and we'll get to that later, but I'm going to have you guys just leave it as this right now, right? Because you're having each term over the fraction to reduce down. We haven't got to that point yet, but yes. If you want to do it now, go for it. You should have got 2x minus 3. 2x minus 3 for your answer. Yep, definitely. That's good if you can do it that, actually. Okay. One more example. Here we go. Copy that one down. That same chart right next to it, 4x plus 2y is equal to 10. I'm going to jump right into it. I'm going to get y for my value, or sorry, my variable. Drop it to my next line. What's my x term? It's 4x, right? So I want to be able to add or subtract it. Subtract it. Subtract 4x from both sides. My 4x and negative 4x are going to cancel, leaving me 2y. is equal to negative 4x plus 10. Can reduce those. Those are not like terms. Then do what to it? Divide by the coefficient of y, which is 2. We're going to simplify. My 2 and 2 are going to give me 1, which will leave me y is equal to negative 4x plus 10 all over 2. Which some of you guys can reduce it, which is okay. You guys ready for your homework? Sure? No?
Oh my God.